Hello, anatomy colleagues. This is Dr. Alsup, and in this video, we are going to be focusing on the connective tissue associated with muscle. And connective tissue is hugely important. Muscles are much more than just the actual muscle cells and the muscle belly. You have to have this connective tissue to actually connect to bone. So we're going to talk about the different layers of the connective tissue. We have two learning objectives to remember, and I want you to answer these in your own words at the end of this video. Now, it may not be intuitive at first, but skeletal muscle is much more than just the muscle cells or the muscle belly. Connective tissue surrounds the different levels of the muscle, from the microscopic to the more external, and it is this connective tissue that is actually connecting to the bone. Skeletal muscle does not actually touch or attach to the bone. There is always connective tissue between them, even if it's not very visible. But oftentimes, those tendons, which are connective tissue, are visible. And all of this connective tissue, from the microscopic to the external, are going to be continuous with the more visible connective tissues like the tendons and oftentimes even the fascia that surrounds muscle compartments. The connective tissue that surrounds an individual muscle cell or muscle fibers, you sometimes hear a muscle cell called a muscle fiber. This is going to be called the endomysium. And you can break this word down. Endo means within, and then the my, means has something to do with muscle. So it makes sense. This is going to be within the muscle. And this is a very thin sheath of areolar connective tissue, which creates room for blood capillaries and nerve fibers to travel, and it will provide protection to those structures. Next, we have the perimysium, with peri meaning around, and this connective tissue will be around a collection of muscle cells called a fascicle. And a fascicle is going to, as mentioned, be a collection of muscle cells. Fascicle size can vary greatly, from having about 10 muscle cells to up to 100 muscle cells bundled together by this perimysium. And some of these larger bundles can be seen pretty easily with the naked eye. In fact, this is what gives a cut of meat the characteristic grain. So if you tear a cooked piece of meat or a tender meat, it rips along the fascicles, and these fascicles can be separated because of this perimysium surrounding it. Epimysium is the connective tissue surrounding the entire muscle belly, so it is upon the muscle. So if you are looking at a muscle and it appears glistening, it is this epimysium that is giving it that glistening appearance. The muscle cells in the belly of the muscle eventually will taper to kind of round, blunt ends, but that connective tissue is going to continue beyond the muscle cells and head towards bone. And this is where tendons come in. This is the continuation of all those connective tissue layers I just discussed beyond the actual muscle cells and muscle belly. Tendons, simply put, will connect muscle to bone, and all muscles have them. There are no muscle cells that attach directly to bone. There's always a tendon, even if it's not really easy to see. When one is discussing a muscle, they are often including the tendon component too. And this is true with something, say, like a muscle strain. These can include injuries to the muscle itself or the muscle's tendon. Now, a tendon will likely take a little bit longer to heal than the muscle tissue, because it is very poorly vascularized, and we know that we need that vascular supply in order to heal. Tendons come in many shapes and sizes. When I first think of a tendon, I first think of the Achilles tendon, which is really called the calcaneal tendon, which is in the back of the ankle region. This is the strongest tendon in the body. It's long and thick and very obvious, and you can easily palpate it on yourself. But Conversely, some tendons are so short they are not visible to the naked eye. And some tendons are flattened and form kind of these broad sheets. These are specifically called an aponeurosis. And one of the more prominent ones of these is right in the front of the abdomen, which we will discuss more in upcoming videos. Lastly, we have fascia, which is grossly visible connective tissue that is not a tendon or a ligament. These generally are broad bands of connective tissue. They're also relatively thin, but they can be thickened in areas. They will support and surround muscles, but it's important to note that they don't just surround muscles. Fascia surrounds other organs as well. It is literally all over the body. But when we're talking about muscles, particularly in the upper and lower limbs, these muscles are grouped in compartments, often separated from each other by fascia. We call these muscle compartments. And the muscles in these compartments have similar actions and neurovascular supply. All right, practice question time. Which answer shows the correct order from most microscopic to most external? Pause the video, mark off the answers you know are wrong, and then let's discuss together. So I think maybe we should start with what is the most internal or microscopic connective tissue layer. Well, it would be the one surrounding the cell, the muscle cell. Endo means within, so that should be first. So we can mark off B and C because they don't have endomysium first. So already got two of them off. That's great. Epi means upon. Think of connective tissue upon the muscle belly. So that would be the most external. So A is incorrect too because it has epimysium right here in the middle. So that leaves us with D as the correct answer. So you have endomysium as the most microscopic around a muscle cell. Perimysium is going to surround fascicles, and the epimysium will surround the entirety of the muscle belly. Excellent. Hopefully you're feeling good about this content, and I thank you for your time and attention.